Okay, so now we're going to focus on light waves, and it's often called geometric optics when we look at what's called the ray nature of light. And so for the ray nature of light, we know that waves behave in a sinusoidal fashion. And if we have a collective wave, kind of a bunch of light waves moving together, and they all have their their crests kind of uniform, rather than look at kind of the individual like crest and trough nature of the actual wave, what we look at is kind of like the direction of propagation of the wave. And so we can kind of see that the crests are moving in this direction. And so we look at what's called the ray nature of light and say, okay, well, collectively the light wave is moving off in this direction. Okay? It's an easier way for us to analyze both mathematically and just conceptually light waves. So that's the ray nature of light. This is geometric optics. There's a separate study of optics called physical optics, where we are looking more at like the sinusoidal wave nature of light. But right now we're going to focus kind of zooming out from the sine waves and focusing on just like the direction of movement of that light. Okay. So with that being said, that kind of qualifying our studies, the first thing I want to talk about is what's called reflection. And so reflection is when a wave hits a boundary and a portion of the wave reflects back into the original medium. I'm just going back and forth and dancing here. And reflection doesn't just occur with light waves, like an echo is a reflection, where the sound wave travels, it hits like a wall or a barrier, it bounces back, okay? The law of reflection, when we are thinking about a light wave, says that when the angle of incidence at which a light wave strikes a boundary is equal to the angle of reflection off of the boundary. And so for a visual of this, let's say I have an interface, like this is medium 1. And a medium is just a material, guys. It's just a fancy way of saying material. So medium 1, medium 2. And if I have my light ray, that's not a very straight line, is it? If I have my light ray and it strikes my interface, it's going to reflect off at the same angle. Now here's what's key, is where is that angle measured from? That angle is measured from what's called a normal, okay? And this kind of is a little bit of takeaway from mechanics. The normal is perpendicular to the interface, okay? So here's medium 1, medium 2, my normal is perpendicular to those two. And so you have right here this theta 1 and this theta 2, and the law of reflection says that theta 1 is equal to theta 2, okay? And that's always, always, always. Now, there are cases where my interface is not smooth, and I have what's called a diffuse reflection. So the video is going to shift, because I'm terrible at drawing this, so I'm going to shift to more of like a pictorial diagram, and I'll explain the difference between a nice clean reflection versus a diffuse reflection.
There's what's called regular or specular reflection, and this occurs when the interface between the two mediums is very smooth. And what happens is that all the reflected rays are parallel to each other. And we get a nice smooth image, essentially. Irregular or diffuse reflection is when the interface between the two mediums is rough. And the result is that the reflected rays are not parallel. And the image is distorted. So this is the difference between looking at yourself in a mirror, like at home, where you have a mirror and it's very smooth. You have basically a very thin layer of metal, and then you have a coating of glass, and the glass is very smooth. And so when you look at yourself in the reflection, it's not a distorted image. Like it looks like what you actually look like. Whereas if you go and use like a public restroom, like on the beach or at the park, and they pretty much just put like a piece of metal as the mirror, and it's not a smooth surface, it's a really rough surface. And so you can see that there's like some fleshy blob in the mirror, but you can't really tell it's you because it's not a smooth surface. And so all those reflected rays are coming back anti parallel, non parallel. And so it doesn't form a clear image from what it was before.